Okay, hope you had a good break and ready to start some physics again. I know it's sometimes a stressful thing to go through what we're going through right now, but hopefully you take every day to appreciate the good things that you have. Just try to stay positive. Well, I wanted to go through some of these notes here. First of all, you should have these notes in your packet that we've had before. Um, just a little bit on how to be safe with current right here. Current only flows if there's a potential difference. And another word for potential difference is voltage. So like a battery, if it's a 9-volt battery, it basically means there's 9 volts on one side and 0 volts on the other, and there's the difference between the ends of the battery. So what's some examples? Like if you touch a 120-volt wire and a ground wire in the other hand, well, that would shock you because there's a difference between your hands, and the current would try to flow from the 120 through you to get to that 0 volt for the ground wire, which is 0 volt. What if you touch a 120-volt wire while standing barefoot on damp grass? That would be bad too, because that damp grass, barefoot, you're basically grounding yourself, giving the electrons a place to get to. If you touch the 120-volt in one hand, your other hand was in your pocket, and you had shoes with rubber soles, that's kind of the demo I did. If you just touch that 120-volt all on its own, you're going to be fine, but don't do that at home because there's always a possibility of you leaning on something the wrong way or something. DC current is like a battery. It flows in one direction. We actually have AC current, which means the electrons move back and forth 60 times every second. Just some general notes there. The important thing is, well, what's going to come next? Well, what's a series circuit? There's where it has one path around. Which of these would be series? It would be these two below here, because that's one path around the battery. Parallel would be these examples. It's going to have more than one pathway. And what we're going to be doing in the next few days is learning how to find all the currents, voltages, and resistances for that whole entire circuit. So let me scroll through this page here again. I'm just going to go over this for about 5 minutes here, 10 minutes, and this is really important to understand this part right here. It's going to help you understand the rest of the unit. Kirchhoff used conservation of energy to describe what happened with current moving through, to describe what happened to the voltage. Voltage is energy per charge. So as electrons move through a circuit, they're going to gain energy in sources. So where does the electron gain energy? A source is considered like a battery or a power supply. It's going to be where the electrons gain their energy from. Where do they lose their energy? Well, in the labs you did, hopefully you saw that it would lose it in what's called loads, which could be a resistor type of a load, but any other device that changes the energy into something else. So resistor is going to change it into heat. You could have things change it into sound or light movement. But what's important is conservation of energy. We went through that before. And the total energy gained or energy lost equals the amount gained. So these are always going to be equal to each other. And then what he did is think of conservation of charge to think about what happens to the current. Electric charge is neither created or destroyed. We went through that before. Sorry about my writing. It's hard to write with this pen. Destroyed or created, you can't do that. It's just there. And current is the flow of electrons. So that means you really can't destroy current. So he came up with these two laws trying to figure out what happens to voltage and current in a circuit. The voltage law goes back to this whole energy idea, because voltage is energy per charge. And he said if you pick a path through a circuit, the sum of the increases, if you added up all the energy you gain from a battery or power source, is going to equal the sum of the decreases. It means you're going to lose whatever you gained, and you can't lose more or less than that in the circuit. And then with the current law, what he did is go back to, and he thought about the conservation of charge. You can't destroy it, or created. So at any junction point, a junction point is where a wire meets another wire. This is like a junction point right there. Or if you have a resistor here, here's a junction point there. It's just where things are connected. And he says the total current into the junction always has to equal the current out. You can't lose it. So that explains the formulas for series and parallel circuits. So again, here's a parallel circuit, the left ones, and here's a series circuit. If we were to write a formula or equation for current or voltage for each one, let's think how that works. IT or I0 stands for the total or the overall or the initial current. And in a parallel circuit, if I have current leaving this battery, say this is 4 amps that leave here, well, how much will go through each? It might get split up differently, but it's going to get split up. If these were equal resistors, it's just going to split it up equally. And so each one of these sum the current. And you would call one of these I1 and you'd call the other one an I2. And so what that means about current in the parallel circuit is the current that you started with here is going to equal these two currents added together. So as an equation, you'd say it equals I1 plus I2. And if you had more than that for resistors, you'd have an equation. But how does current work in a series circuit? What did I push? If current leaves this battery, it's going to go through this light, and it would go through the next light, and we can the same current. You can't create or destroy it. So if I had 4 amps leave this battery, 4 amps are going to go through this first light, and 4 amps through the second light. Remember, current is actual physical electrons. Imagine these as cars down the highway. If you have 4 leave this road right here, all 4 cars would have to go through both of these lights to get back to the other side of the battery. That's what the current's trying to do. But on this one, if you had 4 cars leave, well, 2 might be able to go this way and 2 might be able to go this way. And then they're going to meet up again and 4 continue and 4 cars get back to the garage. So how current works in a series, all the currents are equal. It never got split up. However many lights you have here, all the currents are equal. The voltage is the energy. And so Kirchhoff said, well, how does voltage work? Well, the increases equal the decreases. You're going to gain energy from the battery and you lose it through the resistors. So for the parallel example, if I had a 9-volt battery across right here, how many lights does one electron get to go through? Just one light bulb. Take a look at your PhET simulated labs that we've done. The electron starts from this battery and it will go through one and then go through the wire. It splits up, but each individual electron only goes through one light. So that means these voltages are all going to equal each other. Every branch gets to use that energy. But in a series circuit like this one, if you have current leave, if you had a 9-volt battery here, well, if this light bulb took the 9 volts, there'd be no more energy left for the other one. So what it does is that these 2 light bulbs right here together get to use the energy the battery gave you. So that means that V1 plus V2, these voltages added, would equal the voltage you had at the beginning. And if more resistors, it would be plus however many you have. Now, tomorrow, we're going to start talking about resistances, so I'm going to ignore that for now. But hopefully this gets you a good start on last week is what we're catching up on, and hopefully you're getting a good grip on last week. Take care. I'm going to sign off here and see me if you have any questions. All right. I thought I was signing off, but I forgot I wanted to go over some of the practices that you've had last week. And if there's more questions, I'll be available for a Google Meet tonight. Let's look at this one on currents. We just discussed what happens to current. So if you had 2 amps leave this, and this is a series circuit, I know it's a series circuit, right? Because there's only one resistor here. I just realized I cannot write with this pen on here. Yeah, I got this now. I'm still learning this. So currents. Let's see how currents work. Say this first example. Current that leaves this battery. And this is a series circuit for this first example. So the current will just go through all of those resistors. If I see this 2 amps right here, that's current. That's the current that came from the battery. That means that's how much current would be going through that 6 ohm resistor, or the 3 ohm, or that 21 ohm resistor. Now in parallel, it's a little tricky because the current gets split up here. But how does it get split up? You know it's always true is that I equals V over R, that Ohm's law that we had before. That's always going to be true. So let's think about this. We actually first have to think about how voltages work. And we just went through that. But here I have 45 amps leave and I have a 63 volt battery here. Well, the 3 ohms and 3 ohms, those are going to have to be the same. So that means this has to be 21 amps. Now we know that all 3 of these have to add up to be this initial current. So ignore what I just said about I is V over R. That's always true, but we're going to get back to that. But for this one here, I know that the total IT has to equal the first current plus the second through that second resistor plus that resistor. So how can I find this missing one? I'm going to just subtract these two from that total current that I have. So if I had 45 amps minus 21 minus 21, it's going to equal I3 there. So that should give me 3 amps. One way to check your answer is that the biggest resistor here is going to have the least amount of current. A way to almost check your answer. Let's go through one that's a little bit trickier, because they do get trickier here. Because there's some combination circuits. So let's think about this one here, right here. Now, if I have I10 is 1 amp, what that's telling me is that 1 amp is going down here. That's the same resistance. So that means the current is going to get split up equally here. That means that one has to also be 1 amp. If I had 1 amp go through here and 1 amp go through here, how much current would have gone through here? Well, it's going to have to be 2 amps because that has to be the current that I started with. So this is going to be 2 amps, and that means I had to have 2 amps come from the battery. You see how that works? 2 amps leaves, 2 amps through here, and it gets split up into one of these. Try something a little bit trickier. Say this one right here. I'm sorry. I'm not going to start this over, so here I go. Okay, I'm going to do this one here. I have 2 amps leave this battery. So do we know how much would go through this 5 ohms? It's going to have to be 2 amps. That's the series part of the circuit. So instead of just memorizing the formulas that currents are always equal in a series or that they add up in parallel, just think about what current is. Physical electrons moving through, they all have to go through here. And then when it gets to this point, it could split up. How does it get split up? Well, it's going to get split up equally or not. It ends up that this 4 ohm and this 6 ohm, we're going to work on adding resistors later also, but that's going to add up to be 10 ohms. They just add up because it's one right after the other. And that's how much I have on the other side. So that means this is going to get split up equally, and that one will have 1 amp go through here because I had 2 amps, so split up 2, and 1 amp gets to go down here through this 10 ohm. But then how much goes through this 4 and this 6? Well, 1 amp goes this way. It's going to go through that 4 ohm and through that 6 ohm. It's the same current that gets through both of those. And then how much is this 15? Let's think about that. 1. You have 1 amp that goes down this branch, 1 amp down here. So it's going to meet up again, and 2 amps would go through that 15 ohm. So I'll post these answers up, check your other answers, and see me tonight if there's other questions. I'm also going to go over a few voltage ideas here, so bear with me. I'll be right back. Okay, so here's voltages. How voltages work in a series circuit, if you remember, what I get from the battery equals what I'm losing in those resistors. This is losing 12 volts through this resistor, 18 in that one, and 20 in that one. That total voltage just be these all added together. 12 plus 18 plus 20. I'm going to get 50 volts for my answer. Now let's say we looked at a parallel circuit.